Hello, I hope you can hear me. And this is the review for the second exam. So let's hope this works. I will do my best to make this work. It's going to take a little while to work all these problems, so I may end up having to do more than one video. We will see. And I see my video. It's pretty bright in the background, but such is life when the sun is out. Okay, so it says simplify the expression. So usually when you have a parentheses, you look in the parentheses and see if you can do anything as far as simplify. So if you had some x's upstairs and downstairs, you would want to cancel any commons first, but there's nothing to do. So then you use the power rule, and each item inside gets the power. And this is technically 3 to the first. So every item that has an exponent gets that outside exponent, and the power rule is b to the m to the n equals b to the m times n. And mainly what that means is whatever, you always power to power, meaning you multiply. Okay, if you have a power to a power, you multiply. So you would multiply on the 3's, you would multiply that one exponent. So you would have a 3 to the 4th, x to the 4th to the 4th, which is an x to the 16th, right? Because you're multiplying the exponents. Y to the 2nd to the 4th, 2 times 4 is 8, over z to the 8th, because that 2 also is taken to the 4th power. So then you have 3 to the 4th, which is 81, and you can't do anything else. X to the 16th, y to the 8th, over z to the 8th. And that's your final answer. That's all you can do. Something that confuses people is, when do I multiply the powers or the exponents and when do I add them? For example, if you had x cubed times x to the 4th, then you would add them because that's the product rule. So you would have an x to the 7th, okay? So that's separate, of course. But in this case, you're taking a power to a power. So that's number one. I'll try to scroll down if it'll let me. So I'm having trouble scrolling down. I guess I need to learn how to use my mouse. There we go. And then I need to clear my screen. So bear with me. Every time I do this, I still have to get used to it again because I don't do it very often. So here you look at, what am I doing? And you are here, draw. Sorry. You are subtracting here. So what you want to do, especially when you're subtracting, you want to distribute that negative sign through, meaning everything inside is subtracted. So what you'll do is you need to take a step, put one extra step in, don't try to combine these all at once, and you need to distribute the negative sign. Negative times negative is positive. Negative times positive is negative. And negative times negative is positive. And then you say, well, do I have any like terms? You have 3 apples minus 7 apples, or think dollars. I always say think money. If I have $3 in my account and then I write a check for $7, I'll have a negative 4n to the 7th in this case, plus 6n to the 4th, plus 17n to the 4th. So you combine them. So you have a total of 23n to the 4th. And then you have a negative 8 and a positive 9. And if you had negative 8 in your checking account and you deposit 9, you have positive 1. And this is the end. So that's the end of the story on that one. So now I need my mouse again. And then I'll clear my screen again. I'm trying to be fast because some of these are going to take a while. So on number 3, it says multiply. So yes, our exam online is similar to the exam review, very similar. However, you might be given, you're going to multiply some polynomials, and you might be given a binomial and a binomial. So, you know, if you have a 5x plus 2 and an x minus 3, for example, then you would FOIL that, you know, first, outer, inner, last. and then you would combine like terms if you have some. Sometimes when you multiply, you have something like this item down here that I put, because why did I put this here? Because maybe the one online looks similar to this. I just want you to realize this is multiplication, right? This is multiplication. So this is like you saying this is a -1y cubed. So you could write it or think of it as 3 times -1 and a y cubed times a y cubed, and then you follow the rules. So you have 3 times -1 is a -3, and then you have a product, meaning you're going to add your exponent. So you have y cubed times y cubed is y to the 3 plus 3, which is y to the 6. So if this were the problem, these are just monomials that you're multiplying. So people get confused by the way something looks, but this is multiplying a monomial by a monomial. So then you just take the coefficients, multiply them. Okay, and then in this case here, I'm going to clear the drawings. You have a binomial times a trinomial. So what you do is you multiply through, you multiply all the first one time through. So z times z squared is z cubed. Z times 6z is plus 6z squared. Z times -6 is -6z. And then I'll change colors. Then you have a -6 times z squared, so it's -6z squared. You have a -6 times a positive 6z, which is a -36z. And then you have a -6 times a -6, which makes a positive 36. And now you're going to take all the like terms and combine them. So you have a z cubed, you have 6z squared minus 6z squared, so that's gone. You borrow $6, and you borrow another $36, so you owe $42. Now remember, when you're combining like terms, you don't change the exponents, okay? And then you have a 36 hanging there. That's the end of that one. So hopefully all this helps. I need a mouse. Okay. Now we're going to divide. Okay, the key on dividing, people get so confused. When you are dividing, if it's dividing by a monomial, so this is what I do in class, I would say if you're dividing by a monomial, the key is to split, meaning you split each term. Every single thing you see is divided by that 3x to the 4th. So I would tell students, hey, write it like this. That way you don't have issues and you don't make mistakes. And yes, it takes a little longer, but you know what? It's worth it if you know what you're doing and you get full points. And then you simplify each one. So if you have a 9, you know, the first item could be written as 3 times 3, and then you could write it like this. That's a lot of work, tedious. And then you have this going on here, 4 factors of that. So these 2 would cancel, then we'd cancel 1, 2, 3, and 4. And then you say, what's left? 3x squared, and where is it? Technically upstairs, so we just leave it as is because we don't write it as over 1. Negative, 24 divided by 3 is 8. X to the 4th over x to the 4th is x to the 0, which is 1, or they all cancel. Here, the rule was x on the first item, x to the 4th, 6 over x to the 4th is technically, if you want to use the quotient rule, 6 minus 4, which is x squared, you see? I like the canceling better, especially if the denominator or the exponent in the bottom is bigger. So x to the 4th over x to the 4th, if you like using the quotient rule, is x to the 4 minus 4 is x to the 0, and x to the 0 is always 1. The rule was, and you guys don't know this necessarily, anything to the 0 power is 1, okay? So it disappears. 8 times 1 is 1. End of story. Okay, and then the next one is plus 21x squared over 3x to the 4th. So I'm going to do this over here on the right. It's 3 times 7xx. 3, 1, 2, 3, 4. If you do it this way, it's not necessary, but it might help you not mess it up. X is upstairs and downstairs cancel, the 3's cancel, and then you say, what's left? Oh, I have a 7 upstairs, and I have an x squared left downstairs, and then this is your final answer. You see? This is why the canceling helps. Or, you know, like if you ever have 6 over 36, what's left? If you cancel them, it's not a 6, it's 1 over 6. So that's kind of important that you keep that in mind. All the basic rules still apply. Okay, so I'm going to cancel all the drawings and mouse. Okay, number 5. I'm trying to go somewhat fast because I know that time is valuable and this is not 19 or 20 problems and some of them get pretty involved. Okay, so if you do divide by a binomial, so this is division, if it's a binomial, by a binomial, meaning you're dividing by a binomial, then you need to do long division. And this process is shown in the book. Shouldn't struggle with it. You know what? It's the same thing as if you did 3 goes into, I don't know, let me make something up, 2, 6, I don't know, I'm just making this up. But if I asked you today to divide 3 into 26,258, and I said do it without a calculator, the process is the same. What do you do first? You divide. 3 goes into 2, never. 3 goes into 26, how many times? Well, the most you can fit is 8. So the first thing you did was you divided. Then you do what? You multiply this. Nobody ever has a problem when I show them this process. They're like, oh yeah, we do that all the time. 8 times 3 is 24. So you multiplied, right? That's the second thing you did, the 8 times 3. Then you do what? Subtract. And when you subtract, don't you draw a line? We need this for the longer process. And then you change the sign of the bottom number, don't you? So you draw the line and change that sign here into a minus. So then 26 minus 2, 24 is 2. And then what do? You bring down the next one. So this is daddy, mommy, sister, brother. And that's how I teach it in class because it helps. So then you bring down that 2, don't you? And then what do? Then you repeat. So people get weirdly confused here, but really you repeat. What do? You ask, you're technically asking, 3 goes into 22. How many times? And it's not a clean fraction. So 3 goes into 22. Well, 7 times 3 is 21. And then you say, well, now I'm going to draw my line, change my sign, draw the line, change the sign. I went opposite direction. And then you get a 1, and then you bring down that 5. And once you bring 1 down, you start over. So then you say 3 goes into 15. How many times? 5. 5 times 3 is 15. And in this case, I made that number up, so it doesn't always work the way I want. Now you're going to draw the line, change your sign, and you get a 0 in this case. Then you bring down the 8. And then you say 3 goes into 8. How many times? 2. 2 times 3 is 6. Draw the line, change my sign, and you get 8 minus 6 is 2. And so you would say 8752, remainder 2. That's how you were taught back in the olden days. Now we're going to use the same process when we do the long division on a polynomial. We put this thing in the front, and then we put this underneath. Okay, so your first question, so you don't ask p plus 9 goes into it, you just ask, you start with the p, and you say p goes into p squared how many times, and in class people say, well, that's 2, or they don't know what to do. So I'm going to ask you, if when you ask this, you could write it like this, p goes into p squared, right? Because you're asking how many times does it fit? And isn't that then just p times, you see? So p goes into p squared, p times. So you did your dividing, daddy's turn. And then you do the multiplying. So the thing that's a little different here, where over here, oh, where did I have that? There's a spotlight. Over here, oops, spotlight. So here, after you divide it and you had that 8, then you multiply that 8 times that 3. And my mouse doesn't like this. the 8 times the 3. What we're going to do here is we're going to multiply this p, oops, sorry. We're going to multiply this p through. So p times p and then p times 9. So let me show you how that works. P times p is p squared, and p times 9. So we're going to do this. P times p is p squared. P times 9 is 9p, and it's positive. And then you draw your line and change each sign. So this was a plus, now it's a minus. And I always circle my new sign so I don't get confused. P squared minus p squared is gone. 4p minus 9p is negative 5p. So over there, once you subtracted, you brought down the next one. Well, that's exactly what we do here. We just subtracted, and now we're going to bring down the next one. And then we start over. And I'm going to use a different color. Now we're going to ask, what do we ask now? We're really asking p goes into negative 5p how many times? Do you see? P goes into negative 5p. How many times? The p's cancel, so you get a negative 5. So you have to put a negative 5 here. Then it's time to multiply because we just divided. So we're going to say negative 5 times p is negative 5p. Negative 5 times 9 is negative 45. Then we draw the line and change each sign. So this becomes a plus and this becomes a plus. So I have a negative 5p plus 5p cancels, and the first one always has to cancel, but I didn't force it. Some people just cancel it. The work doesn't make sense. So negative 38 plus 45 is 7, I hope. And then this is the thing that's the remainder. Well, you can't just write remainder. You have to say, well, is it a positive or negative? It's a positive. So up here, we're going to put plus, and then we put the remainder over the original denominator. Okay, so this is my remainder over the original denominator. And then this whole thing here is my final answer. Okay. Okay, so clear. If anything doesn't make sense, you email me and have me do it again so I can explain it better or something. Okay, now let's see. Back to, I'm going to get blue this time. Let's see. Factor out the greatest common factor. So it's always this. I say factor, you say greatest common factor. So then deciding what's the greatest common factor. Well, that's the hard part. In this case, we have a 48, we have a 36, and let's not worry about signs, and we have an 84. Okay, if you wanted to, you could take this apart and break it down into primes. What is 48? 6 times 8, 2 times 4, 2 times 2, 2 times 3. So let's look at this separately. 36 is 6 times 6. So you have a 2 and a 3, and a 2 and a 3. So these are factors. These are the prime factors. That's where I'm going with this one. If you multiply all those back together, then you'd get the 48 on one of them, you'd get the 36 on the other one. 84 is 2 times 42. 42 is 2 times 21. And 21 is 3 times 7. So these are the prime factors that make up 84. So what you're looking for in the greatest common factor, see, because if you pull a 2, yes, that is a common factor. Or if you pull a 3, that is a common factor, but it's not the greatest. So you need to look at, hey, I see a 2, really a greatest common factor. It's a little funny, but it's the least I see it, meaning it's inside all of them. So there are 2 2s inside all of them. You see it? There's 2 2s inside all of them. And then I have 1 3 inside the 48 and inside the 84. And then I have nothing else in common, I don't think. So my GCF, as far as the numbers, is really 2 times 2 is 4 times 3 is 12. So what you would do is on the number part, you would pull a 12 forward. And I always ask students, pull it forward, because then whatever is in the parentheses fits exactly right. So what's this, the m's that's in all of them? There are 2 of them inside all of them. So you pull that to m squared. And then you say, hey, 12m squared times something has to be 48m to the 8th if you're going to go back. So what is 12 times what is 48? So you can just figure that out with a calculator. You're allowed a calculator. 12 times 4 is 48. M squared times what is m to the 8th? M to the 6th, because when you multiply, you add the exponents, right? Minus 12 times what is 36? 3 times 12 is 36. M squared times what is m to the 5th? M cubed. 12m squared times what is 84? Well, I don't see this as easily as some maybe. So I'm not really seeing it. So if I don't see it, I guess if I touch this, it makes weird stuff. So I hope you can see my pointer even when I don't touch it. You see how this 84 is made up of 2 times 2 times 3 times 7? And do you see that 2 times 2 times 3 is the 12? And that whatever's left here, that 7 there, that is what needs to go inside here. So you can use that, or you can use a calculator. And I always encourage people to use a calculator, but know how to use the calculator. And I'm sorry, I'm so lost now. Okay. So 7. 12 times 7 is 84, and then it just doesn't get any m's because the m's are already right there. 12m squared times 7 is 84m squared. True. This is all you do. And I know you're already learning how to, or you've already learned how to factor a trinomial. That trinomial does not factor further. And if all you get is 2 points, take a little hint that that's probably not going to be so too work intensive. Okay, so let's clear all this. And gosh, I hope this recording is working, because I've done that before where I sat there for an hour and made a video and then realized it didn't record. I don't see a recording running. That makes me nervous. Okay, factor by grouping. First of all, if all I said was factor, you could completely ignore everything else really, and then it's your job to see what needs to be done. So if you have 4 terms, do you see how you have 4 terms? First, you should always still ask, is there GCF, meaning is there greatest common factor? But when you look at this, between all 4 terms, the 25 just had 5s in it, and the 24 doesn't have a 5 in it. So you can't pull a GCF out of all of them. But then you say, well, how many terms do I have? Then if you have 4 terms, you group. And the grouping, I always say double bubble. I do not like the way the book shows it usually in a parentheses-like thing, because when you make it into a parentheses, you want to end up foiling, and that's dangerous because that doesn't work. So I'm always saying in class, I say double bubble. So I'm going to say if you factor by grouping, the steps are first, double bubble. After you pull a GCF, if there is one, double bubble or group the 2 items together. Then from each group, you pull the GCF, greatest common factor. So in the first group, do you see how they have something in common? Yes, they have a 2, but they have a, well, hang on a minute. There's a 2 in all of them. Is there more? There's a 4, right? So you've got to be careful. And I'm on the spot here, so my basic math, that's where I mess up. 4 is in both 24 and 20, and there's also an x inside both of those. So you pull the greatest common factor from the first group, and that's 4x. 4x times what is 24x squared? 6x. 4x times what is negative 20x? Negative 5. Do you see how everything you do in this chapter, which is chapter 6, you can check by doing chapter 5, because it's really chapter 5 in reverse, or yes, it's so multiplying through and factoring, there, you can undo one with the other. Then you bring down this sign. So if it's a negative, you need to bring down a negative, but it's a plus. And then they both have a 5. And then you say 5 times what is 30x? 6x. 5 times what is negative 25? Negative 5. And then, so we pulled, step 1 was double bubble. Step 2, from each group, pull the GCF. Step 3, you're gonna now, you need to recognize that you have now 2 terms. So you went, and I wanna highlight this. You went from 1, 2, 3, 4 terms to 1, 2 terms, because terms are separated by plus, minus, and equal signs. So there is that plus. So there's multiplication here. So this is one bigger, uglier term, really. So you went from 4 terms to 2 terms. Well, your goal in the end, when you factor, your goal is to go to 1 term total. So you see how these 2 terms have something in common. It's this. They both have this. So we're going to pull the greatest common and an binomial factor. It just happens to be a binomial. And if this doesn't happen, it means you're not factoring by grouping, okay? So what do? You pull that thing forward, and then you put the leftovers, is what I call them, into the second set of parentheses. This seems to be the easiest for students, but do you see how now you have one big ugly term? Because it's all multiplication here. So that's done. So for step 4, put leftovers. And I know this isn't book speak, but this really helps people because we all like leftovers in the second set. And then some people factor a little differently, and they'll ask me, well, I was taught back in high school to take the 4x plus 5 and then to take the 6x minus 5 and put it behind it. And they ask me, is this correct? And I'm going to ask you, are those not the same? Isn't it true in math that A times B is B times A? Right? 2 times 3 equals 3 times 2. This is called commutative property of multiplication. So it doesn't matter which one's first. Okay, so mouse. All right, now clear. Factor the trinomial, and it doesn't even have to say trinomial, it could just say factor. So step 1 is always you pull the GCF if there is one. Well, there's nothing between a 7 and a 2, so you can't pull anything forward. You know, because if you could pull something forward, you would have a regular x squared. So for example, if you have an x squared minus 5x plus 6, I would not ask you to do it the way I'm going to show you here on number 8. When a trinomial, this is a different section. There's 2 sections. You have one factoring trinomials whose leading coefficient is 1, which if you look at this leader here is really 1. So what I tell students in class, if you have a simple trinomial, keep it simple. So it's simple is not a term that most people like to use, but in here, I think it's great. This is a simple trinomial. So use simply open, close, and you put an x and an x, because if you go back and you multiply that, x times x is x squared, true. And then what you do is you have your product here. I always do this with that slash, but you have a product here, and the product is a 6, and you have a sum here, and the sum is a -5. And then you play around here with and find 2 values that make that true. You know, 1 times 6 is 6, and 1 minus 6 is -5. But you can't use this. See, and this is where people get confused. And some of you would have used it 2 and 3 anyway. But, you know, 1 times -6 is -6, so that doesn't work. But when you add them together, it works for the -5. So be very careful with the 6s and the 1s, because sometimes it's a 2 and a 3, or 6s and 5. Sometimes it's 2 and 3, and sometimes it's 6 and 1. So then you play with this and you say, well, 2 times 3 is 6, but 2 plus 3 is +5. So if you make both of those negative, then you have -2 times -3 is +6, true. And borrow 2, borrow 3, 5, true. So these are the 2 values that you simply put in there. And then if you check this by FOIL, you know, to check, you should always check. X times x is x squared minus 3x minus 2x. -2 times -3 is +6. And in order to do all of this, of course, you have to understand chapter 5 sum, you know, where you're multiplying everything. But this brings you back to the original. You should always check chapter 6 by using chapter 5. So that we know that this is true. Now, long story on this, I just don't want you to use the method that I'm going to show on this one if you don't have to. So if it's simple, keep it simple. Now this one here isn't simple because the leading coefficient is 7, not 1. So you're going to have to go over the top. This is how I teach it in class. So in the book, it'll have a trial and guess check or trial and check method or something, guess and check. Like some people take this and they immediately say, well, I have a 7x and an x. And then they stumble around and play with these values here and with these signs, negative, negative, plus, negative, negative, plus. And they mess around with this until they stumble upon the two that give them the negative 5, 5 and the negative 2. I don't teach it that way because most of my students can't do it. Out of 100 students, 1 can do it. So if you like doing that guess and check method, go for it if you can handle it. But I'm going to teach it the way it always works. So if you have a trinomial whose leading coefficient is not 1, you want to factor by grouping. And the way you factor by grouping, well, when do you group? You group when you have 4 terms. Well, you don't have 4 terms, so you need to first create 4 terms. You see? But it's worth it. It seems like there's an extra step, but it helps you, especially if you know how to factor by grouping already from the previous one. So what we do is we go over the top. We call this over the top. So over the top. And what we do is we say we have a product, which I always put in the top, and a sum in the bottom. So the product is 7 times negative 2, negative 14. This is where the over the top comes from. We take the coefficient by the constant in the back. 7 times negative 2 is negative 14, okay? And then the sum is still that middle number, negative 5, the coefficient of the middle term. So now we look for 2 numbers that give me negative 14 when I'm multiplying, and they give me a negative 5 when I add them. So I have a negative 7 and a positive 2. Negative 7 times 2 is negative 14, true. Negative 7 plus 2 is negative 5, true. So what I do with these is I split the middle term. And the book teaches this. It just calls it factoring by grouping. What we do is we leave the first one alone. We leave the last one alone. And I like doing all the arrows. It seems to help students. And then we split the middle into those 2 items that we found. We have a negative 7. And don't just put negative 7 plus 2. It has to be negative 7x plus 2x. Because when you combine them back, this is how the negative 5 happens, right? And now you're going to double bubble, which you already know how to double bubble, you see? Because now we're going to do now factor by grouping, which I already have the steps of those on the last one. Excuse my handwriting. I do have a pen here, but it's never been good and it's not going to get better. Okay, first group. What do they have in common? They both have a 7. They both have an x. Open. 7x times what is 7x squared? X. 7 times what is negative 7x? Negative 1. Close. Bring that sign down. Plus 2. Open. 2 times x is 2x. 2 times negative 1 is negative 2. True. Now you have 2 terms. They have a common binomial factor. I'm going to pull that forward, put the leftovers in the second set, and now I'm done because completely factored. And if you check it by foiling, it will go back to the original. Okay, I might stop after 10 and make 2 videos because the last one especially is going to take a while. It's a word problem, you know, you've seen that already. Okay, clear drawings, get the mouse. I'm getting a little better. Technology. So, it tells me it's a perfect square trinomial. I don't usually like that. What I usually do is I tell students, hey, I say factor, you say greatest common factor, is there one? You look between the 25 and the 36. Look at this. The 25 is 5 times 5 and the XX, and then you have 36 is 2 times 3 times 2 times 3, you know, 6 times whatever. And then they have nothing in common. So that doesn't work. Then you say, well, she just told us what to do if the leading coefficient is not 1. So you would take it 25 times 36. 25 times 36 is huge. So we say, no, thank you. Okay? That's what I say. So that's going to be a huge number, and then you have to fumble around and mess around. And this particular one might be not so bad, but if you have something with an 81 x squared, and then here you have a 36 hanging around, and then some middle term, 81 times 30, it'll be impossible. So we're going to say, well, that didn't look so good. Then we say, well, maybe it's special. And then I did give you, it's not on here on this review, but within your exam, you have the formulas given to you. And the formula is, one of the formulas is a squared plus 2ab plus b squared factors into a plus b quantity squared. And then you have the other one, a squared minus 2ab plus b squared factors into a minus b quantity squared. And my students in class always hate this stuff. They say, I don't like these formulas, I don't want to get used to them. But when we get to this particular problem, they start embracing that formula because it makes your life so much easier. So when you get a number, if you do over the top and you get some big number, then you want to say, maybe it's special. So let's look at this. This is a trinomial. This over here is a trinomial, you see, and it has the same signs. Now let's see if it's maybe special. So we're going to say, is this something squared? And what would that something be? Well, if you square 5, you get a 25, and if you square an x, you get an x squared. So a is 5x. And then you would say, well, is this something squared? 36. Well, yeah, you say, that's 6 squared. So b, the thing that you square, would be 6. Not 36, but 6. And then you ask yourself, is this 2ab? So I tell students, hey, take the a times the b and then double it. So you're going to take the a times the b, and what do you get? You get 30x. 30x times 2 is 60x true. And then you say, yay, because you can go straight to formula. And you're simply going to say, hey, I have an a, I have a b. I'm going to use my formula. It's a binomial squared. You see this thing here? And you have an a, you have a b. Your b is 6 because you identified it. And then you simply use whatever sign there is and make that a minus. And this is the end of the story. And you didn't have to do it the long way. You can factor this by grouping, but it's going to be a struggle. Okay, so embrace the formulas. But you do have to recognize what would be squared to give you the first one, what's squared to give the last one, and then see if the middle one is a times b and doubled. Okay. We're through, I'd say, the worst of it, but maybe not. Now, this one here, I have to say, yes, on the last test, someone complained, hey, my exam wasn't exactly like the review. Well, this exam shouldn't be exactly like the review, and I actually have lots of colleagues who give you no review because you should learn how to do things and then apply them. I try to take the pressure off a little bit with testing, and I try to give you something that, oh yeah, I remember seeing this, and then it's less intimidating, and I want you to be able to think and not freak out on me. So when you have a binomial, so if it's a binomial, you're going to ask, is it a difference of squares? And that means it needs to be a difference, meaning a minus sign, and then it needs to be something squared and something squared. And a difference of squares, you just memorize the formula, and it's simply a squared minus b squared is a plus b times a minus b. And I am giving you the formulas. I'd advise you to write them down because you're allowed scratch paper, blank scratch paper, and you just write them down the first time. and then you just need to figure out which one to use. On this one, it makes no sense to use a trinomial formula. So if it's a binomial, you should know this and simply say, well, what squared gives me x to the fourth? So what would a be? A would be x squared, you see, because x squared is x to the fourth. So if this thing is your a squared is a squared, right? So b, what would b be if b squared is 81? B is 9. So you say, oh, and it's a difference. It has to be a difference or it won't work. So then you say, oh, great, I love these. A squared minus b squared is a plus b times a minus b. And then you always need to ask yourself, am I done? And then I teach students, you see how this is a binomial. On a binomial, we only have difference of squares and then we have cubes, sum of cubes and difference of cubes. But when it comes to a sum of squares, I'll write this right here, sum of squares. Oh, chicken scratch. Leave it alone. Sum of squares is prime. You cannot factor a sum of squares. So do you see how this is a sum? So you can say, well, that stays because there's nothing I can do to it, and it needs to stay what it is because the sum of squares is prime. But this is a difference of squares. You see, it's a difference, meaning a minus. So you would have to factor this into a difference of squares factors into a plus b times a minus b. Well, what's a in this case? X, because x squared is x squared. What would b be if b squared is 9? 3. And don't worry about signs. When we use formulas, you don't worry about signs. So you have an x plus 3 and an x minus 3. And if you do it any other way, it won't check. The order can be different. You know, if you want to do x squared plus 9, x minus 3, x plus 3, it'll still check. That's not a problem. But some people take that x squared plus 9 and take it apart. It will not check back into the original. Okay. So I hope that makes sense. So if you check this back, you would take these two and multiply them, you know, x squared minus 3x plus 3x. So x squared minus 3x plus 3x cancels. 3 times negative 3 is negative 9. And then you would take this and multiply it back through, and you would end up back up here in the original. So, but I just want you to be aware, not everything in the test looks exactly the way this does, and that's not the way you should be studying anyway. So what if you have something that looks more like, I've made myself a few examples, because this could happen to you. Okay, so if you say, hey, this is if you immediately say, that's a lot of students do this, they say, oh, that's a difference of squares, and a is 4x squared, because if you square that whole thing, you get 16x to the fourth, and b is 8x, then you're going to have a problem because your final answer will not be completely factored. So I'm going to tell you, don't do this. You always try to pull a GCF before you ever start saying, is it a binomial? Is it a trinomial? Is it simple? Is it over the top? What is it? You always try to pull a GCF. In this particular case, there wasn't one. You know, there's nothing in common between x to the fourth and 81. But in this particular case, there is something in common. Look at this one. What do? You should say, hey, they both have a 16 in them. You might only see the 2, you might only see the 4, you know, you might even see an 8, but they do have a 16 in them, and they both have an x squared. So the first thing you do is you pull the GCF, and then you say 16x squared times what is 16x to the fourth, x squared, and 16x squared times what is negative 64x squared, 16 times 4, right? Now you say, am I done? Well, this thing is done. The first part is done. But the second part is the difference of squares, because it's a difference. And A is X and B would be 2. So then you continue factoring this and call it an X plus 2 and an X minus 2. And then watch. Sometimes you can continue doing more. But when you're done, you always ask, is there something that you can pull from there? And there's nothing once it's just an X to the first. Okay, so we've done 10 problems. And we have a bunch more. Whoops. So let's look ahead. And they're not always in exactly the same order on the test either. So I think on the test, if I remember right, you were solving some equations here first before you move on into the domain thing and simplifying rational expressions. So if you look at this thing, you know, you're first doing some things from chapter 7, and then you have to solve some items. So we'll get into that. But let's call this the first half of the video, and then we'll start up again. Whoops, we'll start up some more here. Oh, I need to grab this. Okay, so I'm gonna start up right there on the next video. Stop share. Oh, and stop the video.